Hello, and welcome to Freud's educational video, Entry Doors Made Simple. I'm Vernon Sides with Freud, and I'll be guiding you through today's project. It's a good idea to watch this video in its entirety and read through the instructions on the poster before tackling the project yourself. Additional information is also available on the DVD for you to download to your computer. First, let me congratulate you on your purchase of Freud's high-quality entry door router bit set, the first ever router bit set that lets you create your very own interior and exterior doors with the ability to create tenons of any length. This revolutionary set allows you to build high-quality, 1 3/4 thick exterior doors or 1 3/8 thick interior doors. Plus, you can even build beautiful sidelights and transoms in virtually any size or style. Before we get into constructing our door, I want to introduce you to Cliff Paddock, who will be walking us through the creation of our beautiful custom entry door. Welcome, Cliff.
Thanks, Vernon. I'm excited to show everyone just how versatile and easy to use this set really is. If you look at the set that you just purchased, you'll notice that you have a perfectly matched pair of rail and stile bits. Our bits are assembled for 1 3/4 inch thick entry doors like this. To learn how to adjust the bits for different size doors, check out the special video section, Configuring Your Router Bits.
So what's unique about door construction?
Well, there are a number of elements that make up the door unit. It includes the frame, also called a jamb set, the hinge door, sometimes called a door panel, and many include side lights or a transom above the door.
Cliff, this is my first door project. Can you help me with the terminology?
Let's take a look at a door up close. The stiles are the vertical elements of the door, the side light, or the transom. Rails are horizontal components of the door, side light, or transom. Then we also have raised panels that fit into the rails and stiles.
So why can't I just go buy a door and hang it in the existing opening in my house?
You can buy doors in standard sizes, but the selection of designs and wood species is very limited. There are shops that will build custom doors, but they are very expensive. So Freud created this set to take the headache out of upgrading the doors in your home.
So besides creating my own custom door, what makes this set so special?
What's truly unique about this set is the ability to create tenons of virtually any length easily, which is especially useful when you want to create extra strong load-bearing joints. I'll demonstrate this capability later on when we cut our tenons.
Okay, Cliff, so what do we need to get started?
A complete list of everything that you'll need for the entry door project is listed on the poster, but I'll quickly walk around the shop and show you a few of the tools we'll be using today. You may want to stop the video now and refer to the poster to be sure you have everything you need before you continue. In addition to the router bit set that you already have, you'll need a raised panel bit to profile the panels for our door. Raised panel bits without back cutters are generally designed for either 5/8 inch or 3/4 inch thick material, and Freud offers a variety of them in many profiles. For this application, it's necessary to use a bit that's designed for 3/4 inch thick material, such as Freud's 99515 raised panel bit. You also will need a router.
Now, Cliff, will any router do?
Great question, Vernon. It's best to use a 3 1/4 horsepower router, like Freud's FT2200 or FT3000. A 2 1/4 horsepower router, like Freud's new FT1700, also can be used, but be sure to consult the router user's manual before running any router bit in it. You also will need a router table with a fence, a miter gauge, and 2 or more feather boards. The use of a shop vacuum or dust collector with your router table is strongly recommended. Here we have our table saw that we'll use to rip our stiles and rails to their finished width, and we'll use these roller stands to support our long boards. A benchtop mortiser will be used to finish our mortise and tenon joints. Some other materials we'll use as we go along today include glue, clamps, a straight edge, and of course our lumber. For our door, we've chosen to use red oak.
Cliff, why have you chosen red oak?
Well, red oak is one of the most commonly available hardwoods, but the type of lumber you choose is entirely up to you. You can use almost any type of hardwood and many softwoods.
Oh, good to know. Is there anything that we need to look for when buying our lumber?
Definitely. Choose your stock with care. Lumber for door construction must be perfectly straight and free from defects such as knots, splits, and checks. And get enough stock to build a complete door unit, plus some extra stock for making test cuts. Test cuts help you avoid making mistakes in your good material.
All woodworking projects start with safety first. There's a complete list of safety precautions in the poster that came with your new set that you must follow throughout this video and any time you're woodworking. First and foremost, you should read and obey all the safety instructions and warnings in the operator's manual that came with all of your tools and accessories. Also, be sure to turn off and unplug all power tools when changing cutters or making adjustments, and keep your hands away from sharp cutting edges. Finally, be sure that your machine guards are securely in place. Pause the video now to read all the safety instructions in the posters and manuals before continuing. Cliff, this really is a beautiful door. What do we need to know before we begin our door project?
Prior to beginning a door construction project of this type, contact your local building authority for information about local codes for door construction and installation. This video is only intended to illustrate the steps involved in door construction. Make sure you're familiar with and obey all applicable building codes.
That's a great point. And depending on where you live, your local building codes may have very special requirements, particularly if you live in an area prone to severe weather. It's important to plan your project carefully before purchasing any materials. Cliff, what if this is my first door construction project?
If this is your first door construction project, or if you are building a complex unit with sidelights and transoms, it may be helpful to draw out the rails, stiles, and other elements full size to serve as a construction blueprint. If your project requires that you build a new door jamb set, allow for the thickness of the jamb elements as you calculate your dimensions.
Cliff, how do I determine the size of our door parts?
The detailed formulas for calculating the sizes of your door parts can be found on the poster or at freudtools.com. But first, you need to determine the overall size of the door you're creating and the style. For our project, we're going to create a door unit that includes 2 sidelights, the door panel, and a transom. The door panel and sidelights will have glass inserts at the top and wooden raised panels at the bottom. The hinge door panel will measure 36 inches by 80 inches. The overall size of the complete unit will be 65 inches by 101 inches. Next, you need to determine the widths of your rails and stiles. If you've already picked out decorative glass for your door unit, you may need to adjust the width of your rails and stiles. But for our door, we're going with 4 3/4 inch wide outside stiles and a 4 inch wide center stile. Our sidelight and transom stiles will be 2 1/2 inches wide.
Seems straightforward enough. How would I determine the length of my stiles?
The stiles of the door panel and sidelights should be equal to the finished height of the door panel. In other words, for a common 80-inch high door panel, the stiles would also be 80 inches. Let's move on to sizing our rails. For the width of our rails, we're going to make a top rail that is 5 inches wide, a middle rail that is 6 inches wide, and a bottom rail that is 9 inches wide.
Why 3 different rail widths?
That's mainly just for visual appeal, Vernon.
Okay, so the stiles are covered. How do we determine the length of our rails?
Determining the length of your rails will be a different story. There are a number of factors that will determine your rail lengths, such as the width of your stiles and the length of the tenon you plan to use. For many joints in your door, as well as any stile and rail joints and sidelights and transoms, you can use the rail bit or coping bit to produce a 1/2 inch long stub tenon.
Okay. What do we have here, Cliff?
This innovative rail bit allows you to produce tenons of virtually any length. For our project, we'll produce 3 different types of tenon: the stub tenon, the extended tenon, and the haunch tenon.
Okay, Cliff, is there a formula for calculating the length of a rail with a stub tenon?
The rails will be equal to the finished width of the door panel or sidelight minus the width of the stiles plus the length of the tenon. For extended and haunch tenons, refer to the poster for specific formulas.
Okay, Cliff, I understand the various tenon joints that you showed me how to make. Wouldn't it be easier to use the same tenon joint for the entire door?
Well, Vernon, the longer tenons provide the greatest strength, so they are used at the load-bearing joints of the door, which are the most likely to endure great stress.
Okay, now, I noticed earlier, looking at this long tenon, the question comes to mind, how do you make this joint with this router bit?
Actually, it's quite easy. and now's a good time for me to demonstrate the versatility of the rail bit. I've loosened this bit ahead of time to demonstrate how the top cutter and bearing assembly of the bit is simply unscrewed from the lower cutter and the shank. This adjustment allows you to create a tenon of any length.
I see. By making multiple passes, you make your joint.
That's right, Vernon. And you can do it without ever removing the bit from the router or changing the height of the cutter. For the load-bearing joints of our 36-inch wide door, we're going to create tenons that are 2 1/2 inches in length. For doors that are 32 inches wide or narrower, a minimum tenon length of 2 inches is a good rule of thumb. Again, these formulas can be found on your poster as well as freudtools.com.
What about the glass and the panels?
Sizing the panels depends upon how many panels you'll have in the door, as well as whether you will be using glass. To calculate your panel width, measure the distance between the stiles and add 3/4 inch. This allows for a 1/8 inch expansion on each side of the panel. To calculate your panel length, measure the distance between the rails and add 7/8 inch. This allows for a 1/16 inch expansion on each end of the panel.
We know it's important to allow for expansion of the panels as humidity changes affect the wood. But Cliff, why would we not allow an 1/8 inch expansion around the entire panel?
That's a great question, Vernon. Panels will tend to expand more across their width or across the grain than they will expand along their length or with the grain.
Interesting fact, Cliff. What's next?
We have one more thing to cover, and that's our decorative glass. Adding decorative glass to your door will certainly give it a touch of class and distinction. When ordering your glass, be certain that the dimensions provided by the supplier are the actual sizes of the glass. To calculate the width of your glass, measure the distance between the stiles and add 3/4 inch. To calculate the length, do the same, but measure the distance between the rails.
Now, Cliff, where do I go to find decorative glass?
There are a number of sources of decorative door glass. Contact your local glass suppliers for more information. Now let's start cutting our door parts. We used a thickness planer ahead of time to mill all of our stock to its final thickness. Then we ripped it to width using Freud's LM72R heavy-duty ripping blade, which gave us a flawless finish. To cut our parts to length, we'll simply use a miter saw and Freud's LU91R thin curve sliding miter blade.
That is a beautiful piece of oak. If you don't have a thickness planer in your shop, many lumber dealers or millwork shops will plane stock for an extra charge.
Let's move right into routing our stub tenons in our rail ends. First, always make sure the router is off and unplugged before installing or changing a bit. Handle the bit with care. These carbide edges are very sharp. Our rail bit is already installed in our router. The rail bit has 2 cutters separated by a ball bearing. Make sure that 80% of the bit shank is inserted in the router and tighten the bit securely in the collet. Next, we'll set the height of the bit so that it's vertically centered in the stock. I've made 2 pencil marks on the face of the stock to indicate the location of our 5/8 inch thick stub tenon. We will now adjust the router so that the top and bottom cutters are aligned with those marks. Now we'll use our straight edge to align the infeed and outfeed fences of the router table with the ball bearing on the bit. Be certain that the fence is parallel to the miter track. Now rotate the bit carefully by hand to be certain that the cutting edges do not come in contact with any part of the fence, router table, or router. Now we can plug in our router, connect our dust collector, Put on our eye protection, hearing protection, and use the miter gauge to make our test cut. Now we'll use our calipers to determine whether the stub tenon is properly centered in our workpiece. I can see that the stub tenon is about 15 thousandths of an inch off-center towards the bottom of the workpiece. That means I need to raise my router bit slightly. If your cut is off-center towards the top of the workpiece, you'd need to lower your router bit. Once you get your height right, place your rails face down on the table, put on your eye protection, ear protection, plug in the router, and route the end of all your rails with the stub tenon. If you notice a slight tear out on the back side of the cut, don't worry, this will be cleaned up when we route our style profile later on. Now that we've cut our rail ends with the stub tenons, we can move on to routing our rails with the extended tenons. With the router unplugged, engage the router shaft lock or use a wrench to hold the router spindle. Now use either a 1/4 inch hex wrench or a 1/4 inch socket wrench to unscrew the upper portion of the router bit. You won't need to change the height of the router bit or the router. With the bit already in place, you can continue to make tenons as long as you want simply by moving the fence back. Be extremely careful not to touch the sharp cutting edges as you remove the upper portion of the router bit. For our extended tenons, we're going to move the fence back 1/2 inch from the position we used for the stub tenons. Again, be certain that the router fence remains parallel to the router miter gauge track. Be sure the bit will rotate freely and not contact the fence, the table, or the router before plugging the router in. Long tenons should be routed in multiple passes. With the face side of the rails down, we'll use our miter gauge to push the workpiece forward through the first pass. Then we'll turn the stock over and make the rail cuts on the other side of each rail. You'll repeat this step until you've reached the desired length for your tenons. Put on your safety glasses and hearing protection before plugging the router in.
Okay, Cliff, so far we've routed the tenons on our rails. Are we ready to move on to the stiles?
That's right, Vernon. Now we're going to route the profiles on the edges of our stiles using the stile cutter. The stile cutter is the bit with 2 profiles separated by 2 slotting cutters. Now let's move over to the router table, and I'll show you how to adjust the height of the bit to match the stub tenon. Use one of the completed stub tenon rail ends as a guide to set your cutter height. The top of the groove cutter and the top of the stub tenon should line up perfectly.
Now, Cliff, do we make this cut in one pass?
It's a good idea to make your cuts with the stile bit in 2 passes. Use your straight edge to set the fence in 1/4 inch from the face of the bearing.
Well, let's get our stiles and get started.
Now that we've made our test cuts and we have the bit set at the proper height, we're ready to route our stile profile. Place your stock face down on the router table and route the stile profile on the inside edge of each rail and stile part. Don't forget to route the mid-rails and center stile on both edges, and use 2 passes exactly as you did for the test cuts.
Now Cliff, I noticed that we're using roller stands and Freud's BF3510 feather boards. Can you explain why that's necessary?
Sure, Vernon. Because our stiles are so long and heavy, we're using roller stands on both the infeed and outfeed sides of the table for extra support. We're using the feather boards to hold our stock down and in against the fence. This is good for safety and to improve the quality of the cut. Now, Vernon, we can put on our eye protection, ear protection, and if you will plug in the router, we'll make our first pass. For our mortise and tenon construction, we're going to create a haunch tenon, where we'll actually remove a portion of the tenon to create a haunch or shoulder.
Why the extra step to haunch the tenon?
This extra step will help us to produce a stronger and more attractive joint and conceal the tenon within the end of the stile. I'll quickly show you how to create a split tenon in our bottom rail, like the one I showed you in the beginning of the video. The split tenon has both an extended and a haunch tenon. There are a number of ways you can create a haunch tenon. You can use a bandsaw, a table saw with a dado set, or even a handsaw and coping saw. We're going to use this handsaw and coping saw to split the tenons in our bottom rail. To accommodate the tenons for our 1 3/4" exterior doors, we'll need to create 5/8" mortises. Using a benchtop mortiser with a 3/8" square mortising chisel, we'll make multiple cuts to create our 5/8" mortise. If you do not have a benchtop mortiser or a drill press with a mortising attachment, there are several other methods for creating mortises with a drill press and brad point bits, Forstner bits, chisels, and router bits.
Instructions for all mortising techniques are available on the poster that came with your video.
I prefer to use a 3/8" mortising chisel for this cut and to make multiple passes. That way I can get a tighter mortise. Now let's put on our eye protection, hearing protection, and we'll start to make the cuts. We've now completed our mortises, including the split mortise at the bottom of the stile. Let's test fit our bottom rail with the split tenon, see how we fit. Looks perfect. We're going to move on to routing our raised panels for our door and side lights. I've installed Freud's bevel profile raised panel bit to really give our door a classic look. For this large diameter Freud bit, set the router speed to 12,000 RPM. To set the cutter height for 1 3/4" thick door panels, set the bit so the top of the cutting edge is 9/16 of an inch above the router table. Next, since we'll be removing a large amount of material, we'll need to do it in several passes for maximum safety. So set the router table fence forward so the cutter removes 1/3 of the material in your test piece. Once you make the first pass in your test piece, You'll make 2 more passes, each time moving the fence back to remove another third of the material. Now we'll put on our eye protection, ear protection, plug in the router, and make our test cuts. Now that we've finished cutting a raised panel in our test stock, we'll dry fit it into the grooves in our stiles. Ours fits perfectly. If your panel is too tight, the bit should be raised slightly. If the panel is too loose, the bit should be lowered slightly. Once you have the desired fit, you can go ahead and route the panels for your door. For best results, route the end grains first, then cut the long grains. This will ensure that you get flawless, clean edges. When you've finished with that side, turn the panel over and do the same thing. To complete your panels, just follow the steps we went through for the test cuts.
Cliff, it looks like we're just about done with our door construction.
Almost, Vernon. We just need to finish dry fitting each part of the door to be sure all the joints will close completely before applying any glue.
Cliff, this is a snug fit.
That's good. They should be snug. If you have to use a mallet to assemble the joints, be sure you use a block of wood to protect the finished surfaces of your door. Okay, let's put on the outside stile here, Vernon.
Okay.
Thank you.
Yes.
Looks like it went together great, Vernon. With our clamps and glue, this will pull together perfectly. I think we got a great finish. Before you begin to assemble your door, here are a couple of tips about gluing and clamping. Apply the glue generously to the edges of your stub tenons, including the edges of the profile. Be sure you cover all surfaces. I like to use a small brush to brush the glue out evenly. Do the same on your extended tenons. Again, be sure you get the edge of the profile as well as the surface of the tenon. If you get any glue on the finished surface of the wood, take a wet rag after you assemble and clean it off completely. It's best if you don't let it dry. Again, be sure you get all the surfaces. After you do your tenons, be sure you get glue in all of the mortises and glue all the other joints of your door, except for the raised panels. The raised panels must not be glued so they can float and expand and contract. Now a couple of tips about clamping. When you clamp your center stile, it's important to protect the upper edge of the mid-rail. I've cut a small block from one of the test pieces we made earlier in the project. Slip that block into the upper edge of the rail, place your clamp against the block. Now you can pull as tightly as you need to without damaging the mid-rail. I also save a couple of pieces of scrap stock to protect the outside edges of my door when I clamp across. Now, let's glue and clamp our door.
Once you have glued and clamped your door, allow the glue to cure as recommended by the manufacturer.
Once the glue is dried completely, remove all clamps and carefully sand all surfaces of the door, sidelights, and transoms prior to finishing.
This concludes our main video segment. We hope that you've enjoyed watching Freud's Entry Doors Made Simple. Be sure to check out the special video sections on this DVD or poster to learn how to install glass in the door unit, build and install door jamb sets, install hinges and hardware, and use glue joints to make large panels. Until next time, I'm Vernon Sides.
And I'm Cliff Paddock. Thanks for supporting Freud. We purchased some beautiful decorative glass to give our door curb appeal and to let natural light into the home. To start the installation, use a sharp flush trim bit like Freud's new 42204 downshear flush trim to remove the inside door profile. Glass is normally installed from the inside of the door. Using a sharp chisel, square the corners of the area that you just routed. Then inspect the surfaces to be sure they're smooth and flat. Next, you'll mill the wooden glass stop. For the best appearance, create the stop from the same material used for the door. We had enough stock left over when we routed our rails and stiles to final size. Make sure you work with stock that's wide enough to handle safely when sawing and routing. You'll route the stock exactly as you routed the stiles earlier in our project. If your stock is wide enough, route both edges to produce 4 pieces of glass stock. Then carefully rip the stop to final size on the table saw. If you're uncertain about safe procedures for ripping narrow pieces of molding, consult your saw manufacturer before proceeding.
Cliff, how do we weatherproof the areas around the glass?
We begin by applying glazing tape to the remaining section of the stile profile. 1/8 inch or 3/32 inch tape is good. Apply the tape on all 4 sides of the opening and fit the tape carefully to avoid gaps. Vernon, let's go ahead and take the backing off the tape. Now we'll apply a sealant to the joints between the sections of tape.
Cliff, are we ready to put our glass in?
Yes, Vernon, but always wear safety glasses and gloves when handling glass. And if you're unfamiliar with handling glass, consult your glass supplier for complete information and safety procedures before proceeding. We're going to carefully place our glass against the glazing tape. Okay, Vernon, now we'll take our glass and very carefully place it in the door.
Cliff, how exactly do we secure our glass in our door?
We'll secure it using the glass stop that we milled earlier. We'll gently fit each piece of the molding into the opening, and then we'll secure it using finish nails or screws. Always pre-drill your molding and use great care to avoid hitting the glass with any fasteners or tools. I like to place a piece of cardboard against the glass to help protect against scratches. If your bits are configured to route 1 3/4 inch thick exterior doors, here's how to reconfigure them to route 1 3/8 inch thick interior doors. Engage the spindle lock on your router and use a 1/2 inch wrench to remove the black nut on the top of the bit. Carefully remove the nut. Remove the top cutter and note the shims on top. Be very careful not to touch the sharp cutting edges. Now remove the 2 1/8 inch spacers that are just on top of the bearing. Replace the top cutter and shims. Place the 2 1/8 inch spacers on top. Replace the black nut. With the spindle lock engaged, tighten the nut securely. Your bits are now adjusted to route 1 3/8 inch thick interior doors. Ready? If your Stile bit is configured to route 1 3/4 thick exterior doors, here's how to reconfigure it to route 1 3/8 thick interior doors. First, engage the router spindle lock, then use a 1/2 inch wrench to loosen the black nut on the top of the bit. Carefully remove the nut. Be careful not to touch the sharp cutting edges. Now remove the top cutter. Notice the shims on the top of the cutter. Remove the bearing and remove the top slotting cutter. Take off the 2 1/8 inch thick spacers. Replace the shims. Replace the slotting cutter, being careful that the carbide edges do not touch each other or touch the steel plate of the adjoining slot cutter. Replace the bearing. Replace the top cutter and shims. Now place the 2 1/8 inch spacers on top. Replace the black nut. And use your wrench to tighten securely. Your bits are now adjusted to route 1 3/8 inch thick interior doors.